Good morning. Welcome to this morning's webinar. It's Mike Lees here, Product Manager, as usual joined by Ed Stanier. Morning, Ed.
Morning, Mike. Morning, everyone.
So let's crack straight in. So today's agenda, a little bit of background. I think most of you are fairly regular now, so I've cut this down a little bit in terms of the background. I think you know where we're coming from. There is a bit of a different change to the agenda format today. Thanks for all the feedback on the last webinar particularly. Ed, I felt that we skipped over some fairly big topics. I mean, nobody complained, but, you know, I wasn't totally confident. Things like VLAN, spanning tree, subnetting, probably didn't do them justice. What do you think?
Yeah, agreed. I mean, they're very big topics, so it's hard to cram everything in within half an hour.
Yeah. So with that in mind, what we've done for the security session is split it over three sessions so we can do it justice. I want to try and keep the webinars to a reasonable length, half an hour, so we're going to do it over 3 and go into a bit more detail, and hopefully you'll get more information. And what we'll probably do then, Ed, is revisit some of the early ones and do some deeper dives.
Absolutely, yeah.
Somebody asked about doing more on subnetting, you know, VLANs, and again, spanning trees probably a subject in its own right.
Yeah, certainly.
So from a security point of view, what we do today is secure management and take a look at port security, and as usual look at Q&A at the end. We've had I think probably 2 or 3 questions, but we've taken all those offline because they've been quite specific to people's applications, and you know, we're happy to pick up those conversations. In fact, we've got a couple of visits lined up, and the message is, you know, we're happy to take things offline, more specific, that maybe aren't useful to the wider audience. And as always, you know, if there aren't any questions through the webinar, then we won't make any up. We'll close it at that point. So, just one quick slide, my favourite slide, a bit of a funny picture, and it's really just acknowledging that, you know, Ethernet, it's a really technical and in-depth subject. And one of the challenges is it can appear quite simple, the way you connect devices together just by going in and whacking into a free port. And that's what creates a lot of problems that we come across. So in terms of how we position this, you know, a lot of engineers now that are doing network maybe haven't come from a networking background, and that makes it even more challenging. So the work that we do, the training and so forth, is very much geared to training from the aspect of an OT engineer who might not be a specialist network engineer and doesn't work with networking day to day. So the webinars until today were based around our training course, which is a 3-day training course. We've actually run the course a couple of times now, Ed, so I guess we're getting more feedback in terms of what people are finding challenging, and so we can start feeding that back into the webinar.
Exactly, yeah.
So the next scheduled course is September. There's people booked on that already, and we can run courses sooner if required. So as you can see from the slide there, networking basics, networking switching, and security, that's the rough format of the course, and it's very hands-on. So again, if there's any questions on that, happy to take them. So let's crack in, Ed. So secure management, I guess here we're really just talking about the fundamentals of talking over a secure or non-secure network.
Yeah, basically, Mike. Yeah, the difference between the two, and on the surface, it obviously seems quite simple. One's a secure channel, one's an insecure channel. But really, it's about understanding the knock-on effects of having these insecure management, you know, protocols running on your network, running on your switches, your firewalls, that kind of thing. And on the training course, we go into quite a lot of detail as to the problem with insecure management protocols is how easily they can be exploited, and we're not talking about, you know, needing a lot of knowledge to exploit them. It's reasonably straightforward with a little bit of know-how and the correct software. They can be very easily exploited, and when I say exploited, what I mean by that is that stealing usernames and passwords, that kind of thing, management information on your switches. An insecure management protocol is essentially one that is transferred over the network in clear text, so there's no encryption or anything like that. And we have a look at just how easy it is to sniff those, so to speak.
I think we've got a slide on that, haven't we, Ed?
We do, here we go. So, nice kind of simple diagram here. On the left-hand side, we've got a standard HTTP connection. Let's assume we're just logging into a normal web server here, but equally this could be a web service on a switch or a router or a firewall or something like that. And it's just to kind of demonstrate there the potential for like a man-in-the-middle attack. So we've got that little icon of a person's head there on the left-hand side, and they're able to intercept and sniff that traffic across the wire. And actually in the training course we do like a demonstration as to just how easy it is to do that. Now as soon as we bring in a secure channel, encryption, in this case HTTPS, then what we're doing is we're setting up, you know, a point-to-point encrypted link between us and the web service, as I said before, whether it's a web server or a switch or something like that. And essentially anyone who attempts to sniff that traffic, intercept it, they will just be met with, you know, encrypted text that will mean absolutely nothing to them unless they're able to get the decryption keys. Now there are still ways that you can exploit HTTPS, but it's a lot more secure than just having, you know, plain text passwords being sent across your network. And the thing about this also is how easy it is to configure your devices to use secure channels as opposed to insecure ones. So it's not a lot of extra configuration work, but, you know, the security benefits you get from it are really quite great.
Why don't we just use HTTPS by default?
Well, I mean, some vendors do. It depends which vendor you're dealing with. Some will actually force it, and particularly on more modern hardware, it's becoming a bit more of a standard. I know there's a couple of Hirschman firewalls that actually now enforce HTTPS connections, so you literally just don't have the ability to connect over an unsecure channel. But that's not to say that other vendors don't, and particularly on old hardware as well, it's still quite the standard. So it's something really you need to be made aware of and see where you can reconfigure it.
Just on a bit more detail, I think. And I noticed you mentioned SSH here. Is this Telnet? Is that?
Yeah, that's right, Mike. Yeah, SSH is the secure equivalent of Telnet. And the actual kind of encryption system, you know, it's called public key cryptography. The way that it works is the same for both HTTPS and SSH. One's obviously just for web management, and one's for, you know, command line management through Telnet or SSH in this case. And this diagram it's probably the simplest way to explain how the encryption works on at least a basic level. It's a very in-depth subject, so we'll just kind of flick through it quickly now. But essentially your laptop, your computer will request a certificate from the web server or the switch or whatever it is you're connected to. The device in question will answer back with its own certificate. From there'll be some validation, some trust that you'll kind of establish with the end device. And after some exchange of keys and some kind of complicated maths in the background that this cryptography all works upon, you'll essentially have a secure channel between the two. And that means that anything then sent over the wire can only be decrypted through the use of the device's private key or your key that you generated when you first established a session. So it's preventing anyone without the decryption keys from being able to do anything with that traffic. So they can still intercept it quite easily, but actually trying to read it and understand, you know, read usernames and passwords, that kind of thing, is practically impossible. The encryption standard is extremely secure, and this is the same standard that we'd use when logging on to Google, Amazon, you know, any big website. Even online banking will use the same encryption standard. And so actually decrypting it, it's practically impossible. Given our current technology, we just can't do it. Yeah, this is just a kind of bit of a comparison really between Telnet and SSH. And these are the standard protocols you'll use to configure Cisco switches, especially, and Cisco routers, Cisco firewalls, they're a lot more focused on command line configuration, and actually a lot of other vendors also offer these, but perhaps try and focus a bit more on web management. But the actual difference between the two, obviously in the table there, SSH is a lot more modern. Telnet was, originally created in the 60s, very, very old protocol, but still used today. And it's a great protocol. The only problem with it is that everything's transmitted in plain text. So when you're logging onto devices, you send in usernames and passwords, and obviously, again, just like with HTTP, they can be intercepted. So SSH overcomes that by using the same encryption we just looked at in the previous slide, and setting up that secure channel before you send anything over the wire. And the only thing really to consider with that is the additional overhead you have. The encryption will add additional traffic, it's additional processing power required by both devices to encrypt and decrypt it. Having said that, with modern hardware and with modern networks being as quick as they are, generally at least 100 meg, in most cases gigabit, the extra bandwidth isn't really an excuse not to use it. So it shouldn't really be too much of a consideration nowadays. There's very little reason not to use SSH. In fact, in my opinion, there's no reason at all not to use it as opposed to Telnet.
Okay. And you mentioned Cisco there, Ed.
Yes.
So Cisco versus Hirschman. So Cisco's more oriented towards SSH, whereas I don't think Hirschman is it? Exactly,
yeah. I think one of the key things with Hirschman kit is ease of configuration and administration. So the way they do that is with nice, easy-to-use web interfaces. Obviously, the downside with that is that their feature set is nowhere near as rich as Cisco's. So generally speaking, with Cisco hardware, you can do a hell of a lot more. However, the actual command line of Cisco is a skill within itself. So configuring certain things on Cisco devices can be quite challenging.
Yeah. I guess that in a way positions our view of Hirschman versus Cisco as
yes.
Hirschman from an OT engineering point of view,
yes,
can be just the job without the complexity of the Cisco command line, but the Cisco is very functionally rich and powerful.
Exactly that.
If you know how to drive it.
Yeah, precisely.
So VLANs, obviously talked about VLANs in the last webinar session, but this is, and we talked about VLANs from a security point of view, but this is a subtly different case, isn't it? This is using VLANs for the actual management traffic.
Yeah, that's right. And by default, and again, this comes back to your contradiction of Ethernet slide. By default, if you start chucking in a bunch of managed switches, everything will be on VLAN 1, the default VLAN, and everything is kind of sent over that VLAN. It's just a flat VLAN structure, if you will. Now, a good kind of security practice is to keep your management interfaces away from your user VLANs. I mean, in this case, this picture here, ideally what we'd do is not use VLAN, excuse me, not use VLAN 1 in the first place. But if we were to keep on VLAN 1 for whatever reason, one of the quick fixes to kind of boost your security would be to take those management interfaces away from VLAN 1 and put them on their own management VLAN. If we can just move to the next slide, Mike, just to give a demonstration. All we've done here then, excuse me, is create a new VLAN, a dedicated management one, and what we can do then is we can lock down the ports and the devices that can access those management interfaces. We can control that to as many or as few ports and devices as we want. Before, on the previous slide, anyone, anywhere within the network could have potentially had access to the management interfaces. Now, that's not to say we've got to use names and passwords, but with a few kind of exploits, it's quite easy to intercept them. And again, especially if you're using insecure management protocols. So by doing this, what we're doing is we're limiting that kind of surface area of attack. If we lock down our management VLAN and only allow one port to connect to it, then that port could be connected to a workstation that's in a secure office. It's an engineering workstation or something. You're limited the amount of people who can even get onto that, and you're greatly increasing your security there for your management interfaces.
Okay. So I think that's the last slide on secure management. And from the point of view they always do in terms of the OT engineer, security, so topical. This is an area that really engineers at least have an appreciation of and get into. Ed, what's your view on that?
Yeah, I mean, security it's a very big subject, and there's a lot of things to consider with it. Having said that, in most cases, from an IT engineer's point of view, obviously they may not want to get or may not have the knowledge to get involved in some of the really more advanced things, but there's some very simple and straightforward quick fixes almost they can do to start bolstering their security.
It kind of leads us nicely into port security, isn't it? I mean, it's one of the fundamentals, and almost always comes up when we're doing our initial security audits on site, and then in the follow-up actions in terms of tidying up the site, it's security 101, if you like.
Exactly, yeah. I think a lot of people, when they think security, they think, right, we've got to get a firewall in, we've got to protect ourselves from the internet, and, obviously all these stories of ransomware and whatnot going on at the moment. But a lot of attacks will come from within, and if you haven't secured your local networks, your access layer, then that's probably one of the first things you want to be focusing on. And it's probably also one of the perhaps easiest ones as well. It just requires a little bit of thought as to what things you want to allow and what ports you need open and that kind of thing. So, yeah, port security is kind of focuses on almost the access layer, all your switches, and really it's about managing those, locking them down as you need them, and restricting them in certain ways. So this is just kind of some of the best practices, and just a nice easy 5 points. And some of these are perhaps a little bit harder than others, but I mean, let's start at the top. The first one, reconfigure all unused ports to a different unused VLAN than VLAN 1 and then disable them. So that's basically saying that we want to avoid the use of VLAN 1 if we can. Now, sometimes in older networks, everything's been configured, everything's working, and it's on VLAN 1, and retrofitting or retro-changing that is quite a big job, and it's not always practical. But if we were to configure a network from scratch, we wouldn't use VLAN 1. We'd decide which ports are connecting to which devices, and then the ones we aren't using, we would reconfigure those to a dead VLAN, if you will, a dummy VLAN, one that isn't used by anything, and then we'd disable them. It's kind of a bit of a double whammy. No one can come in and connect because it's disabled, and if they are accidentally enabled and someone does come in and connect, then they're on a VLAN where nothing else resides. They've got no routes out to the VLANs, they can't sniff any traffic, there's just nothing on there, it's like a black hole. The second one, these are spanning tree features. Spanning tree is great, and it's the industry standard for having a redundant switch network and preventing loops and that kind of thing. The problem with it is there's not a lot of authentication, validation. In fact, there's practically none. So exploiting it is actually quite easy if you understand the protocol. And there are certain features we can put on our switch ports to prevent this kind of thing from happening.
And I think I'll put a slide in later on, actually, on that subject, so we can cover that one.
We'll cover that, yeah, okay. I won't talk too much about that right now, then. So the third point, static MAC address allocations. This can add a fair bit of administrative overhead, but it does really add an extra big layer of security, and it's to kind of lock down your ports so only certain devices can connect through them. We'll come into more detail on that in a bit there. I think we've got a slide for that. We've then got point number 4, DHCP snooping and ARP inspection. We cover this quite heavily on day 3 of a training course, but these are 2 quite common attacks that you may see in a switch network within a LAN. And these are 2 features that some vendors support. Cisco definitely support these, other vendors may or may not. But these are to kind of prevent those attacks. And just really quickly, those are DHCP snooping is to prevent a rogue DHCP server from operating on the network, and ARP inspection is to prevent man-in-the-middle attacks on kind of layer 2. And then for really high-level security, and this perhaps may be a bit out of scope for most people, but it's good to consider. is port authentication, and this is essentially when a user connects to a port, they have to authenticate before they can actually use it. So we'd use like an external radius server or something like that. Perhaps not the most commonly used thing within OT networks, perhaps more on the user side, but it's good to understand how it works and that it is an option there if you need it.
Okay, so you touched on MAC address thing, and I've always discounted this because I thought it was just loads of work and very manual.
Yes, it can be very manual. The basic idea is that you lock a port down to X number of MAC addresses, 1, 2, 3, however many you want, depending what's connected to it. Now, obviously, you can already see the extra overhead there. You're going to have to start writing down MAC addresses and configuring them. Cisco do have some nice little features that make it a lot easier and make it a lot more dynamic. I think one of them is called sticky MAC addresses, where essentially the first device that you plug into the port after configuring it will be assumed to be, the genuine device. So you don't have to go around recording MAC addresses, putting them all in.
Like a learning mode.
Like a learning mode, exactly, yeah. And there's ways you can kind of tweak that. If you had 2 or 3 devices being used there, you could plug them all in, and you can tell it to learn up to, 3, 4, 5, however many MAC addresses you want. So in the Cisco world, there's ways of making this a lot easier, and it is a really good layer of security. It just needs a little bit of thought and consideration before actually doing it. So this is our spanning tree security feature, BPDU Guard. BPDU stands for Bridging Protocol Data Unit, and this is these are like the frames that spanning tree switches will send to each other to communicate and to keep track of a topology and that kind of thing. The problem there is if you've got an access port and someone comes along and plugs in a rogue switch that has a really low priority and attempts to almost take over the spanning tree topology, without BPDU Guard, you've got nothing in place to stop that from happening. And if you were to do an attack similar to this, you could kind of render a network almost unusable. You could force a lot of topology changes and reconvergences, and your network will just be a mess, and you may never be able to communicate on it until you've rectified the problem. And obviously that means no traffic passing from switch to switch. It can be an absolute nightmare. What this does is if it detects a BPDU from your rogue switch, it will shut that port down straight away, stop it from propagating around the network, and that port has to be manually re-enabled then for it to come back up. So generally you'd configure this on every single access port, every non-uplink port that goes to another switch, you'd configure this on. There's no real reason not to.
And it's a familiar question for me. Why isn't this enabled by default? Is it to do with spanning tree being quite old and therefore compatibility?
Kind of. I mean, that's one of the reasons. I think when spanning tree was designed, it didn't really have any validation authentication in mind, really. The reasons behind that, I'm not too sure. I can only speculate. They wanted to keep it nice and simple, and there was that kind of level of trust already. Obviously, that's not the case nowadays. And generally speaking, I mean, some Cisco switches will have this enabled by default, but they're more small business switches that are based, for the office. Your kind of industrial range, catalyst range may or may not. It varies from model to model. And to be honest, there's some vendors, I can't quite comment on Hirschman, I'm not too sure, but some vendors may not even support this. I know for a fact Cisco do, some may or may not.
You're saying you should go around switch by switch and enable this. And I think you've got a final slide, Ed, just going into a bit more detail.
Okay. This is a little bit technical, but yeah, this is another spanning tree security feature, Root Guard. So what this does is when you have your master switch and your spanning tree topology, your root bridge, by enabling this on your uplink ports, you are preventing anyone from being able to become the new root master. So again, with spanning tree, there's little validation, and it's all based on basically one number configured on your switch, which is your priority. And the lower the priority, the better. If we were to plug our rogue switch in with a really low priority, then there's no further questions asked by spanning tree. If it sees a low priority, it says, yep, you're the new master. And obviously that can cause a lot of problems. So this enforces your topology. If your topology is configured, fixed, you're not planning on ever changing it, or at least not for a long time, you'd configure this to stop even an accidental plugging in of a switch or low priority can cause problems. So this is a good security thing, but it's also a good kind of user error thing as well. It'll stop someone from accidentally plugging an old switch with a low priority configured and becoming a new master and causing convergences on your network.
Okay, thanks, Ed. Okay. So, finally, just a quick chat about what's coming up next. So when we looked at the day 3 agenda, we split it into 3 areas. Obviously, the today one, you thought access control lists and firewalls went together?
Yeah, I think they kind of go hand in hand. I mean, they're kind of core functionality of a firewall, really, having access control lists in. Obviously, firewalls offer a lot more features, and a lot of these we'll go through, you know, on the training course on day 3. But really, those two can be grouped together quite logically, so it makes sense to have a webinar on those.
And then a final session on common vulnerabilities.
Yeah, so we'll go into some more technical detail as to some of the things we've talked about earlier, but we'll look at, you know, some of the most common attacks you may have on a local area network, and maybe like a brief explanation and kind of a demonstration almost of how we do those.
Yeah. And I suspect we'll revisit security. Well, I know we'll have to revisit security at some point in the future. Yeah. And actually, the other subjects we go back to, like VLANs and things, there's always a security angle for those type of things as well.
Absolutely, yeah, yeah.
Okay. That's great. Thanks very much. So hopefully you've enjoyed the format today. It felt better to me, Ed, in terms of going into a bit more detail and not just glossing over things and
definitely, yeah,
giving a bit more useful information, but hopefully without going too deep and blowing people's minds.
Yes, yes.
I think I said right back at the first webinar that, you know, we're not going to become networking experts by attending a half-hour webinar once a month, but what we're trying to do is give pointers to people so they can go away and do more learning. And I know people do contact us out of these for asking some extra help, and that's obviously no problem at all. I don't believe any questions have come in, so that's fine, it's no problems. As ever, feel free to pop over some questions afterwards. In terms of more information, a lot of you do download the webinars and distribute them internally. That's great to hear. As ever, if you've got ideas for future webinars, you know, we'd like to get those ideas as well. In terms of why we're doing this, obviously it's fun to talk about network and security. It's what we do. We are a business. This is what we do as a business. So we're obviously looking to talk to you about consultancy opportunities. We're probably running 2 or 3 network audits a month now, I would say, Ed.
Yeah.
That's pretty static, and that means typically going on site 1 or 2 days and then doing a quick report and then following with some actions. The training Ed's mentioned, and of course we are suppliers of both Cisco and Hirschman equipment, and happy to get involved in designing networks from that aspect. So just remains for me to say thanks very much, Ed, for your time. I hope everyone's enjoyed it, and we'll see you again in a month's time. Thank you. Bye-bye.